Greetings. I have been requested to give a short lecture about the concept of function at the basic algebra and college algebra curriculum. So that will be the topic of this lecture. So let's get started. Every definition must be an if and only if statement. Now, a given definition of a subject provides us with the characteristic and information of that subject. Now, definition given in any branch of science in general or in mathematics in particular are all given in a condensed and short sentences. That has advantage and disadvantage. The disadvantage is for the beginner students. They somehow cannot comprehend them, and it sounds to them very abstract and brings about anxiety, in fact, for them. Now, in order to eliminate the kind of abstraction of that and melt away, in a sense, the anxiety, is to teach students the art of paraphrasing and expanding the definition in a full comprehension of the students. And that definitely follows with the examples. So that's what I'm intending to do in this lecture. Now, let's see how basic algebra and college algebra defines what is the definition in those textbooks about the function. They said that function is a rule of correspondence between two non-empty sets known as domain and range. So I'm right now waving my hand. I'm not going through every definition. Assuming that you already know, a student already know. One of them is definition of the set. The other one is domain and range, what they are. Domain, let me quickly go over that, is a set of all permissible values that the independent variable can possess. So again, independent variable, dependent variable, all of this I'm waving my hand and assuming a student are familiar with that. Now, going back to the definition that the textbook makes, is that it says is a rule of correspondence between two non-empty sets such that each element in the set of domain is paired uniquely with an element in the set of range. This is what the textbooks define the definition for function. So let me see how I paraphrase it. I say function is a rule of correspondence between two non-empty sets. We call them input and output, in a sense. We can call it, because we are dealing with function, we can say it domain and the range, the two sets. Now, with respect to this rule of correspondence, there are conditions imposed. And those conditions are as follows. Each element in the set of domain must be uniquely paired with an element from the set of range. What that element is, the rule of correspondence assigns that element. Now, in this condition that I put, the words each, uniqueness, and play very important for the full comprehension of the definition of function. And if you glance and don't give them respect, That is exactly what causes kind of ambiguity and brings about abstraction and anxiety. So they play very important role. So let's investigate and study each of them at the time about imposing on this definition. Now, I have some written so that to be more explicit, I stay out of your way and zoom them so that I can go over them in writing. Let's do it. Shall I? Okay, hopefully it's readable. Now let's talk about the each. Now the domain of my function consists of from negative infinity to 2 union with from 5 to infinity including 5 and 2. Alright? And then the range of my function is the set of all real numbers. And now the function is defined this way. He says for all the numbers less than or equal to 2, from negative infinity all the way to 2 including 2, anything you give as an input, the function will give you odd 7. So you give negative 19, he gives you 7. You give him 0, he gives you 7. You give him 2, he gives you 7. You give him anything else, negative 1,000, he gives you 7. Then when you give him other thing from his domain, let's say when you give him 5, he gives you 3. Then he give you, let's say 17, he gives you 3. You give him 100, he gives you 3. So the function is well defined, we know the domain of that, we know the outcome, and they are uniquely. For example, if you give him, let's say negative 3, he gives you 7, he doesn't give you anything else. So the uniqueness is also applied here. So now in order to make it even more explicit, this one, notice that the interval from 2 to 5 is not in the domain. You notice that the whole entire number line is cut into 2 pieces. From negative infinity to 2, then from 5 to positive infinity. In between them, there is a cut, but is not in the domain of that. You see that? That's very important observation, because we are going to come to that. Now, let's look at the schematic diagram of that. Now, a schematic diagram is not to drop a dark or play with arrow. The schematic diagram improves the conceptual understanding of the subject. So it is important and it's good to pay good attention to that. Correct? Now, here for the same problem, the domain is from negative infinity to 2, including 2, union with 5 to infinity. Now look at the schematic diagram. These numbers are in the set of domains, all of them less than or equal to 2. All of them under F are paired with 7. And 7 is a point on the range. But the word each is not imposed on the set range. The word each is only imposed on the set of domain. So this is 1 point from the set of range. And the same if the number that is given, the input, is bigger than or equal to 5, the output of the function is always 3. So there is no ambiguity. We know what is input, we know what is output, and there is no two different number comes out of it. So this is a nice looking schematic diagram that gives us a good picture of the subject and improves our conceptual understanding of that. So again, I'll repeat myself, we are not playing darts or playing with arrows, but there is a very, very important to pay attention for the schematic diagram. Now look at this one. Please, this is very important to compare because the goal is what? Is to paraphrase and expand it to our full comprehension and look for example and counterexamples. Now here, look at this one. Before the domain of my function was from negative infinity to 2, then from 5 to positive infinity. Now the domain of my function, I'm using the word function by the way, I'll come back to that. The domain of that, the input is what? Is all real numbers this time. Which means from 2 and 3 that was not included in the previous, previous example. Now it is included. And the range of that is all real numbers. All right? Now, we know the input and we know the range. Now look what happens here. Now look what happens here. Here, let me just look at the graph of that, it's more clear. Now, here between 2 and 5 is included. You see, it's from real to real. Is that right? The function, I'm using the word function. And between 3 and 5, the function cannot give anything out. Because from negative infinity to 2, he gives you 7. From 5 to positive infinity, give you 3. So what happens to the numbers between 2 and 5? So that has violated the each, because it's the each element in the domain must be used. So the real number in reality is not the domain of this function. The previously was, this is not the domain, because domain is the set of all permissible values that the independent variable can have. And here from 2 to 5, all the numbers that are infinitely many, they are not permitted to be here. So you cannot use the notation of f of x. You see that? I put a big cross of that. So I can call this one input, but I cannot call it domain. So, but you can use the letter y, and that's most of the textbook they use, and that stands for relation in reality. So this is a relation, but this relation is not a function. So you see how important is the word each. And here, infinitely many points, the function has no value for them. As a matter of fact, this even violates the uniqueness, because we don't know what happens to that. How do you know they are mapped uniquely with each other in infinity? So we have no information about that. So that's about this. Now let's see what will be the schematic diagram of this. Again, a schematic diagram improves our conceptual understanding, a better conceptual understanding of the subject. Now again, for the each, look what happens. This is the input. See, I didn't call it domain. This is the input, and we had no problem with this. They all have paired with something in the range. All right? But look at this one. There are infinitely many points here that they are not mapped to anything. They are not matched with anything. So this schematic diagram indicates that this cannot be a function. So this schematic diagram is not the diagram of a function, but as a relation. But you can use y, but you cannot use f of x, or g of x, or h of x, those that they stand as for the function. It's a notation for the function. Okay. Now let's talk about uniqueness that we use in the definition. Now suppose that my function is from real to real, which means the domain of that, I'm using not the word function, the domain of that is a real number, and the range of that is also real number, and the function is defined to be any number that you give to him, the outcome is 7. And 7 is a point in the range. The range has infinitely many points or real number, but only 7 is our concern. and there is no restriction for the range. Only the each applies for the domain set, remember that. Alright, so this is a very nice looking function, and this is the graph of that. So we can use here f of x, nothing wrong. But look at this one. This is a graph of a circle that we are familiar with, and the domain of that, I shouldn't use the word domain because domain belongs to the function, but just for the sake of the discussion, let's say the domain. The domain of that is from -2 to 2, including 2 and -2. But the outcome now is not unique. For example, if the input is 0, the output is 2 and -2, two of them. So because there is more than one, so we said this is not a function. But this is really the way that we look at the function in the elementary courses, freshman, sophomore. But when you go to the a little bit upper courses, this kind of function is called single valued function. And this kind of relation are called multi-valued function. Again, the use function is used also for this one. But in the freshman level and sophomore level mathematics, we said that is not a function. We said that is a relation. Now the reason those textbooks a little bit hard, they also call them function, but they call them multi-valued function. The reason is that when you give a number, the outcome of them is not random. So there is a discipline. For example, when you give 0 here, the outcome is 2 and -2. So it's not 50 or a randomly selected number. So for that reason, they are called multi-valued, as the literal meaning of the word indicates. More than one value function. So I like this one better. I like to call this one single-valued function and call this one multi-valued function. But that is my preference. Now let's look to see what the word "and" means, how we expand the word "and" in that definition. Indefinite article "and." What role that one plays? I have written like that. So, "and" means what is at least one in our definition of a function. Now it brings about the following kinds of function. With the word "and" comes this kind of function: into function, onto function, one-to-one function, and one-to-one correspondence function. So this word causes this kind of function to pop up. Without that, we couldn't do that. Okay, then now I have the last one that I just read it quickly for you, and I don't go to detail on that because I don't want the lecture to get too long. I'm supposed to give it a short lecture. So it's about notation. Let's see what it means for the notation. Now let me read it for you quickly. F of x, g of x, h of x, etc. are often used to indicate that we are dealing with a function. Now the letter x in f of x can be any other letter or any other symbol, in fact, indicates that the independent variable in the given equality or in the given expression is, or any other symbol that we use in that case, is beside x, they all have this meaning, will be considered as a what, for them, for the function, will be considered as a variable. And any other symbol or any other letters of alphabet beside x in that expression will be considered as a constant. Now I'll make an example. F of x equals 7x squared plus b. Here x is variable, it can assume different values, but b is constant. So b stays same, x starts to get value, then b can be changed. for example, when b is 1, you go and sketch this graph. Then b is 2, you go and sketch this graph. So when b is 2, remains 2, but x start to change. When b is 7, remains 7, but x does not. X start to have different value, and based on that, the graph can be sketched. Now look what happens. Instead of writing f of x equals 7x squared plus b, if I say f of b equals 7b squared plus x, if I write it that way, then the b will be the independent variable and the x will be the constant. So they are all dummy letters of alphabet. They are just dummy symbols. So don't let them to distract your mind through a kind of habit you have. But most of the textbooks, they select x to stand for independent variable, and most of the textbook and almost all over the world, and we are kind of more used to it. But that is not a must, and that is not a standard general in reality. Okay, then let me zoom this one back. Now, I have already uploaded quite many. I don't recall how many, maybe 7, 8, if not 10 lectures, some of them long enough, full hour lecture, about the concept of function and different kind of functions. You can find them in my channel, and I strongly urge you to watch them. They are very informative. And for this lecture, I may give one or more 2 lectures just to back up this one, to give more information about that. And I hope that this lecture was beneficially and useful. And I am doing all these lectures for the benefit of public, and mostly for my fellow American citizen, and then for the rest of the world, and I hope they get benefit out of these lectures. Okay, then, as always, I thank you for watching, and I wish you all prosperity and good health, and please stay and remain healthy. So long.